In this topic, you'll be introduced to the different options that exist in GCP when it comes to leveraging machine learning. First, though, you'll explore the relationship between machine learning, artificial intelligence, and deep learning. A very common question asked: what's the difference between AI, artificial intelligence, machine learning, and deep learning? Well, one way to think about it is AI is the discipline, like something like physics. AI refers to machines that are capable of acting autonomously, machines that think. AI has to do with the theory and methods to build machines that can solve problems by thinking and acting like humans. Machine learning within there is a tool set, like Newton's laws of mechanics. Just as you can use Newton's laws to figure out how long it'll take a ball to drop when it falls off a cliff, you can use machine learning to scalably solve certain kinds of problems using data examples, but without the need for any custom code. Deep learning is a type of machine learning that works even when the data consists of unstructured data like images, speech, video, natural language text, and so on. One kind of deep learning is image classification. A machine can learn how to classify images into categories when it's shown lots of different examples. And the really cool thing about deep learning is that oftentimes in really complex problems, it can do better than a human at it. The basic difference between machine learning and other techniques in AI is that in machine learning, machines learn. They don't start out intelligent, they become intelligent. Back to our example. Let's say we've built a machine learning model to find bad manufactured parts, and then we want to remove them. Quality control is now pretty inexpensive. So what? The business factor motivating us isn't my business will save money. It's I could add quality control throughout our entire manufacturing process. Instead of just doing the quality control at the end of the manufacturing line, we can now insert it everywhere and improve overall quality. The opportunity is for organizations to take advantage of the ease of creating new models to continue to transform their business. So now that you know what ML is, and I hope that you've started to come up with some of those ideas of your own related to ML. Much of the hype around ML now is because the barriers to entry of building these models has fallen dramatically. You don't have to be an astrophysicist to do machine learning. And this is because the convergence of a number of critical factors: the increasing availability of data, the increasing maturity and sophistication of those ML algorithms for you to choose from, and the increasing power and the availability of computing hardware and software through things like cloud computing. Let me show you an example. Imagine we want to build that ML model to identify those diseased leaves to predict the health of the trees. Remember, we can do that using a standard algorithm for image classification. You don't need to have a PhD in image processing. You just need to know which algorithm should you choose off the shelf. But back to our ML model. Another critical ingredient for ML is that data. We need to collect lots of images of leaves. Today you can do that pretty easily with the camera on your phone. Finally, we need the hardware and the software to make that happen. And that's easier now than it has ever been in the past. We can use the cloud to power our ML model so that we can do it cost effectively. Different options exist when it comes to leveraging machine learning. Advanced users who want more control over the building and training of their ML models will use tools that offer the levels of flexibility that they're looking for. And this could involve developing custom models through an ML library like TensorFlow that's supported on AI platform. This option works well for data scientists with the skills and the need to create a custom TensorFlow model. But increasingly, you don't have to do that. Google makes the power of machine learning available to you, even if you have limited knowledge of machine learning. You can use Cloud AutoML, like you're going to do in one of your labs, to build on Google's machine learning capabilities to create your own custom machine learning models that are tailored to your specific business needs, and then integrate those models into applications and websites, all without writing a line of TensorFlow code. Alternatively, Google has a range of pre-trained, meaning you don't need to bring your own data, machine learning models that are ready for immediate use within applications in ways that the respective APIs are designed to support. Such pre-trained models are excellent ways to replace user input with machine learning.